thank you so much for coming. And shortly, I'll introduce myself, and then we're going to go forward with our talk. So my name is Richard, and I'm an iOS developer, Apple ecosystem developer, and I've have quite a few apps or libraries in my portfolio. I work a lot with Swift and security, and you can follow me on those links that I listed. I'm also running a YouTube channel, but you can subscribe to me on all the platforms and find me on LinkedIn if you have any further questions. I work at the company called Raketi, and we have actually quite a few gifts here from our company, from our sponsor who is sponsoring with some gifts. And those gifts will be, there's a cups here, and they will be for the best questions later on in the Q&A section, as usual. So we are Helsinki-based company, and if this talk sounds interesting to you, maybe you're interested in working with this technology, feel free to reach out. Yeah, and as I said, I have a YouTube channel. This talk would be posted on my YouTube channel as well. Feel free to subscribe, and there are also quite a lot of deep technical dives into the iOS-related content. So let's get started. The topic today is Keychain Unlocked, advanced security for smarter and safer apps. And Keychain is a very interesting framework because if you look at the top apps in the App Store, probably every app has some sort of Keychain API usage. In fact, my first app used Keychain. My first ever app for iOS, it already used Keychain. And you'd think that a framework that is so widely used, probably all of these apps use Keychain, every one of them. And you think that all of the apps, they use Keychain, and pretty much this API should be bulletproof and really easy to use, but no. This API actually quite difficult to work with. Today we're going to go through this is the topic list. We're going to go through the basic storing and retrieving data with the keychain, sharing of the keychain items between multiple applications or application extensions, biometry protection, and how can you improve the default security posture of the keychain. Yeah, so what is the keychain? It's a storage framework for sensitive data, passwords, certificates, different kind of credentials. It's backed by SQLite, which is a very robust framework, and it's a C-based API. Handles encryption and decryption in background. It uses the secure enclave in the process, so it doesn't store everything in a secure enclave, but it is used there for encryption and decryption keys, and it's integrated with biometry, app security, groups, app groups, right, and passcode protection. All of these features are working seamlessly. So this is how it looks like, and we're today going to be focusing on the C-based API component. We are going to really look deep into this part. So what is the Keychain API, how it looks like? And this is it. I think it's quite easy, right? Well, not so. It's one of the most complex APIs there for a beginner developer. And the reason is that it's written in C. It's a C-based framework, which means it's a procedural programming language. You have to really spell out every action you want to make. And there are a lot of cons for this. It's very low level. There is no encapsulation for different kind of methods that you would like to add to your data. You pretty much have to write the whole request all out. And there's no predefined data types. So as we've seen earlier, there's lots of different dictionaries passed around with the keys, but no normal like a struct or a class that you might be familiar with. But on the other hand, there is a big benefit to this. It's a very flexible API, so you can really do everything, and you can connect multiple different things together, like biometry with iCloud, with different kind of behaviors. So when your data becomes accessible, like if it's accessible in the background, if it's accessible only when the user unlocks the app, and so forth. So quite a lot of flexibility, actually. And you can bind it to every paradigm you want. You can bind it to functional or object-oriented to SwiftUI. Doesn't matter. You can tailor it to the domain you want to your app really, really well if you want to. So as we know, Swift is Turing complete, which means it's capable of performing any computation a computer can, right? So if it's a C-based framework, we can play with it. We can do it really convenient for us to use. And we can make it procedural. From procedural, we can go to object-oriented, for example. And we really can tweak the API the way we want. And that's what developers usually are doing. They're using these keychain wrappers, which are really popular. As you can see, a lot of them, there are lots of different keychain wrappers. And some of them have like 7,000 stars, the others like 3,000 stars. They are very popular and very different. So we will go a bit deeper and understand why you can have like 10 different keychain wrappers, and each of them will be slightly different version. So yeah, let's build one ourselves. Let's get back to the query that we were working with. The query really consists of three things. First of all is query configuration. As you can see, there is a lot of dictionaries or attributes in the dictionary passed around. And the first thing is you configure query. Essentially, you're asking what you want to do with the keychain. In this case, what are we actually going to do? We're going to retrieve the data. So we are asking for an account, asking for what kind of do we actually want to return the data, and so forth, and also passing the biometry authentication. The second part is actually execution of the query. This is where the magic happens. And the third part is the request and response processing. We analyze what happened, and we analyze whether we can actually get the data. Decoding and encoding of the data happens there, and passing it further to application context. Most of the keychain wrappers, they collapse the whole thing into one single call, so making it convenient to the user. It's very similar to the user defaults that they try to imitate. And one of the challenges with this procedural API, with the C-based API, is that it never returns the data to you directly. So if you take a look at the status, that's an error code. It's not the data what's returned from the method, or actually a function in this context. And the output is actually passed separately as the parameter to the method. And then you check for the output whether there is something, and you check for the status if the operation has been successful. And the status is not like an error or value, of course, it's a number, something like that. This is something you can get. There's an OS status website. It's that you can look up what the actual error code means. In this case, it means that there is this 25,297 means that there is like a duplicate value. And you, I think, trying to add a duplicate value that's already there. Yeah, let's fix this part so that we'll get a proper error, like NS error or Swift error out. That's the first step we really need to do, because you want to get out the clear understanding of what's happening under the hood. The way to do it is I usually create a method that calls a few other methods under the hood. It's seek copy error message string, and you can actually retrieve the user-facing string from the system. Just pass that method, and that's it. I just pass that around as an error. And if something fails, I'll then just throw this error. This is the first step I do. And now let's store some data. So the API of the data storage, the architecture looks something like that. You have the keychain, and you might have multiple services, which is like HTTP client or app settings. It's sort of a group of items stored together. And each of those services will have multiple keys for each value. Like you can have a token stored, or refresh token stored, or password. And all of that stored as the value for that key. It's a classic key value storage. So actually, it's very simple. And Yeah. So Keychain always returns you only data. There's no, it has no understanding of whether it's like a string or Boolean or a number or double. So that's a very important observation. Under the hood, you can store the data in whatever format you really want. And the service has to be included with each request. If you don't do that, it will include a default service for you. And pretty much store, well, you can do that as well. The service will be default one. But you can customize and segregate the different values. And for example, if you want to delete later on only specific section of your app stored in a keychain, like if you want to clear just part of the data, you can just delete the whole service related to that compartment. So we make a class. That's the first step that will store our service name. And then we pass that service as the parameter to any query that we try to execute. We use our default query. It's essentially just a the dictionary, as I said, that you have to configure, and that dictionary has to accept the value of service. And I already predefined the generic password. That's what I will be working with, because Keychain has a couple of other data types that we can store and retrieve. And we return this query. We'll be using this query as our baseline. We'll augment it in some way and change it so that we won't have to retype all of that all the time. The easiest one is to remove the data. That's the easiest way to work with the keychain, the easiest method you can implement. We start with that. So we have that base query, and we modify it by setting the key. And the key is an account. So Keychain has its own terminology. The service is sort of the name of the group of items, and the account is the key. And then you execute the deletion in this case, and checking the result. Essentially, you are looking if the item is not found or if it's success. Those two codes. Then you just skip everything because we like to make the API to be convenient for the developer. Those two error codes really don't need any action from the developer. And if something else, we just create our error that we've created before with the error code and provide the localized description. Now, setting the data is a bit more complex. The first thing you do is actually you remove the data when you set the data, because if you try to overwrite the data, it will fail with a duplicated data error, as I've shown earlier. So you remove the data. That's the first step when you set it. And again, we go with a base query, we modify it, and we just pass our parameters as a dictionary, and we use the add command in this case, and the same error processing as we used before. Then getting data is the most complex. So again, we start with a base query, and we need to the way it works is that you execute a query in the keychain, and it can actually copy multiple values, multiple data pieces, but you need to limit how many of them you want. And usually if you have one key, and you can get one value. And this is where you add the base query, and then you notice that there is like match limit and limit 1. And the funny thing is, like, if you really want the keychain to return the data, you need to actually specify that. The reason why you want it to not return data is the other way. For example, if you want to check that the data is actually there, but without returning it, because you might not have the access to that data. And yeah, you copy the data and process the error if there is any, and if there is no error, you try to extract and decode the data. That's the last piece. And so far, we good to go. We implemented the basics. You notice one thing, that in all of those methods that we've done, we can only get and set the data. We don't really have anything related to strings or integers or any other data types. So how can we go about that? And the answer is we need to implement those data types ourselves based on data. Keychain doesn't care what it stores if it can be converted to data in one way or another. And that's why we have a lot of those different wrappers. They might do the conversion slightly differently, or they might do slightly different API, but under the hood they have the same method calls. And this is how you, for example, might convert a string to a data, just using a normal initializer that tries to encode, tries to get the data and encode it into a string or decode it into a string. And yeah, you specify the encoding and try to request the data. If you get something, you try to decode it and pass to the client. For other data types, for example, integers, Boolean, and double, those are normally required to get a parity with user defaults. One way is to convert them to string through NS number, because NS number can be converted to string and vice versa. Then you can easily get those. You can get those values like number, like integer and Boolean and floating point. And yeah, it looks repetitive, right? And there is really another way to do it. You can achieve the same with the codable. So you parameterize a generic function over type, over a codable type. This is a type constraint. And then you pass the type to the JSON decoder or encoder, and you can convert the data with one method. This method will work pretty much for everything. It will work for integers, all of the floating points, like everything that can be codable. Small structs can be stored there. Although there are some limits, you cannot store like really big pieces of data in the keychain. So just one method does the same work as what we're seeing here. And yeah, this is the example how you use it. You have to pass the you have to tell the compiler what kind of specialization to invoke, and you have to specify the type, because otherwise there will be no information of which type you're trying to query. Is it like a string or Boolean or a number? Now let's go to keychain sharing. So let's remember our schema earlier. It looks like this, and then this is an example. We have two categories, two services in this case, and yeah, let's imagine we want to share this with an app extension or a second app that you have. You have two apps, and you might have like two them sharing together the same authentication token, or you might want to share the same data with the app extension. So the way you can do it is you create a shared keychain, and you can store those shared values, and both of them will have access to this shared keychain. So when we start, it looks like this. You have a group of items, and they're sort of completely independent of each other in each app. And the way you do it is you add a capability in the Xcode. That's the first step, app groups. And there is a previous thing called keychain sharing group. That's a bit older technology. And the keychain sharing group is included into app groups. So I would not recommend using keychain sharing group. Just go with the app groups straight away. And you register it on the developer portal. You select register new app group, and then you create a new group container in your Xcode window that looks something like that. There is like a keychain sharing now, but in case of app group, it will have application group written, so, and the group name. And after you do that, your items will be available for both apps if you initialize the keychain with the with that group name. One of the examples where this is used is all of the password managers. They use it for passing data around with the autofill extension, and also like with the different authenticator apps. If you want to use the autofill extension, that's usually where it's used. Or for example, if you want to have multiple applications running off the same account, like in case of Microsoft, you have like Office, and you authenticate once, you use the same credentials everywhere. So on the code level, this looks something like that. You have service, but now in addition to service, in our class, we have the app group. And you just initialize that and use it later with every request. You just augment each request. Since we did this base query earlier, we just append that group attribute, and it will be included into every invocation of any method that we invoke on our wrapper. And let's take a look at a couple of case studies, real-world challenges implementing the keychain code. One of them, to begin with, is to understand the concept of fail-safe and fail-secure. So normally, you might have this magnetic lock, and actually in some movie, I think it's Die Hard, where they used to disable this magnetic lock by disabling the power. So when the power is disabled, the magnetic lock is losing its function. It's fail-safe because if, for example, fire burns and this lock is not disabled, you will not be able to exit it without the power, right? That's called fail-safe. But sometimes you don't want this. Sometimes you want fail-secure. So in case of the power outage for this vault, you won't be able to get in or out. And this is really what we want to have with a keychain. We want to fail securely. And one of the cases that I've often see with a keychain is the erasing data on reinstallation. As you know, keychain does not erase the data when you reinstall the app. And that usually causes a lot of problems for beginner developers and for more professional developers as well, even who know that. They use some concept similar to this. Usually this code is used where you add some flagging to user defaults and like, is it first launch? And if it is a first launch, if you cannot retrieve this this value, then you erase the keychain from the reinstallation. And then you continue launch and setting that key again. Yeah, it looks good in theory, but the problem is when something with this code fails, your app essentially doesn't log the user out, and your user might see the data of the previous user. That could be one case. Another case that the data is not erased because this code failed in some way. Then the app starts to behave unusually because you, for example, store configuration parameters, especially for very big apps where multiple teams are involved, and you might see some weird behavior feature being enabled or disabled because there are some keychain flags that haven't been cleared. So, and this is actually what the official answer is of the Apple engineer, how to deal with this. If you want to implement the auto-delete feature, you need to enable some secret and scramble the keychain with that secret and store that secret on the disk. And if the app gets deleted, the secret gets deleted, the key gets deleted, and then your data is effectively erased. So let's implement this. The way I would do it, I could use user defaults, for example, because user defaults, we know that they are erased on the reinstallation. So this is how our initializer looks like earlier, and we need to change it a little bit. We add a scrambling key on initializer. This is it. It's a symmetric key using CryptoKit. And normal operation, the key is retrieved from user defaults. And if the key is not retrieved, you know that the data is lost. You can erase data here, but you don't even have to because your data is encrypted and you can't read it anymore. And you just create a new key, which is not compatible with the data already stored. So effectively, once you reinstall the app, your keychain is being cleared automatically because user defaults is erased on reinstallation. This complicates a little bit our method for storing and retrieving data by one more call. So we now need to encrypt and decrypt the data, scramble the data with a scrambling key. But it's not very difficult. You can just add this and do transparently the user of your library, of your Keychain wrapper, will not even know that this is happening under the hood. And now let's go on a second topic. It's the biometric authentication. And more specifically, the question is, how do you check that the biometric status has changed? Let's say the user enrolled a new fingerprint or a new face scan. And the reason you need to know this is that if the user has enrolled a new biometric authentication method, that could be enrolled not by the same user, but by someone else, and you might want to erase your key that you've attached to the biometry, right? So let's say I enrolled my biometry first, and then my relative or someone else enrolled their biometry. I know the key, but I didn't tell the key. So now that person can have the access to the same data that was protected by the key, but he doesn't know the key because it's just the biometric authentication method that is used. So how do you check that there is a change in the biometry? And one way to do it is to use the state variable. That's actually what is recommended. And you use the state can evaluate policy, and then you get the state validated policy domain state, and then you can check if the state is changed or not. And if a state is changed, then it means there is some change in the biometric signature, like a new fingerprint or a new face scan, or it was deleted and then recreated. For example, you have the app and you have like state. It's a string, like 1, 2, 3 or something. This is like an example. And then you get something else, you know that your biometric signature has changed. Pretty easy, right? But the problem is, if you try to match this across the app, if you share the data, the protected data across multiple apps, that wouldn't work. You are getting different keys in different apps. So you know that you can track it across one app, but you cannot know that if you open one app and you only have the data from the previous another app, let's say another app launch, you won't be able to corroborate that. And another challenge is that, especially for password manager apps, is that it doesn't even match across the app extensions. So the corollary to this problem is usually some of the password managers require you to enroll biometry twice. You need to enroll it in the autofill, and you need to enroll it into the main app to authenticate. So how can you enroll only once and then use across your extension and across your main app? And one way to do it is to use the biometric protected keychain. So instead of checking whether the biometric method has changed, we just store the secret with the biometrically protected attribute. And then the item will be erased the moment the biometric signature changes. Another benefit of that is that even if the software has the access to the device, unless the user has authenticated biometrically, the software won't even be able to access the underlying data. And it's quite a huge method, unfortunately. Well, it's Keychain. And the way you do it is, if we zoom in, we set this control attribute. In this case, biometric current set. We create the access control flags, and we create biometric current set. In this case, I also added accessible when device unlocked and this device only, so it will not be shared across the backups and restore operation as well. And we can use it in a very simple way. We just, again, augment our query to, in this case, it's a get query. Then it will toggle the biometric pop-up in this case. Yeah, so conclusion is that the Keychain is a very powerful API, and you can tailor it the way you want for your application. It is quite low level, so you need to know what you're doing, and it takes an effort to develop secure code. Normally, there are, as you've seen, quite many pitfalls that you can face if you're not knowing that might lead to data integrity compromise or some other issues, maybe functional issues. And if a keychain wrappers don't work for you, you make your own. So let's go through Q&A session. And if you have any questions, feel free to ask. We have a mic here. And yeah, let's go through Q&A. And this is the details of me if you want to get in touch.
Hello. Thank you for the talk. Actually, I had a question related to the biometrics. You mentioned, at least it was on the slide, that biometrics, when the state changes, all the data in the keychain that has, of course, the biometric access is deleted. What constitutes actually a biometric state change?
I think the biometric state change in this, well, in this context would be a change in the signature. In this case, different change of the fingerprint or face scan or iris scan. So if you had one face added there, so if you add another face, that will trigger a change. If you have one finger added and you have another finger, that would be a change. If you delete one, I think that will also constitute a change. So any change will trigger that.
So adding a new finger would actually cause this as well?
Yeah, for sure. That's very important. That's what you want, because you are adding additional group of people, right? Because you don't know if this finger belongs to the same person or a different person. You cannot authenticate the person that with the fingerprint. You just know that this finger is authorized to invoke the biometric authentication. That's what you know. But you don't know if the owner of that finger knows the secret protected by the biometry. And because that could be my finger, that could be someone else's finger. And you know it's authorized, the finger is authorized, but you know if the person is actually authorized. So you need to ask for the secret again and store the secret in the keychain. And now you know, because this biometric current set, a new set of the biometric attributes, a new finger set, let's say 2 fingers. I think you can have up to 5 fingers added there. Now you have this new set, and you know that someone from this set added the secret. Someone knows the secret, so he knows that the current set of users is authorized to use it. I'm not sure what happens if you remove a finger, because technically the biometric set changes, so I assume it will actually also trigger the reset. But if you think from the authorization perspective, that might not be the case, because the same people who are authorized, now you reduce the number of people who can have access. So I don't know, but very likely it will just react onto any change of the on the signature. And also, if you change the passcode, I think that will also trigger to trigger a reset of those keys.
Okay, thank you.
I have one question, sorry, about sharing the keychain across apps. So obviously they need to be in the same app group, which means they need to be in the same account. But you talked about app extensions. Are they limited by the same constraints, or they have to be in the same account?
They have to be in the same app group.
Okay, so that means probably they're in the same account also.
Yes,
I guess.
Correct. And this group will have it has to be registered on the Apple developer, so it will even have the group prefix there. So your account, team ID is the first letters there that are not shown here.
Yeah, so you can't share across apps across different Apple accounts.
Across different, I mean developer account, of course. Yeah, I don't think so.
Yeah, exactly.
It's usually, well, the app extension is usually sharing data with its own host app. So
yeah, okay, all right.
It's rarely that it shares. Well, I don't know the cases where it shares something with the some other app, which is not host. So you might have a host app, and you might have the same another app from the same developer that is sharing the data to this shared container. But still, like the first use case is to share it with the host app.
Yeah. Okay. Thanks.
Thanks for the talk. So if I don't care about biometry and I don't care about persisting the data post uninstall, is there any practical reason to use Keychain over user defaults considering iOS sandboxing?
In terms of
security or anything, I mean, user defaults has a much simpler API. It's simpler to use, and you can share it with app groups just as easily. So if I don't have biometry needs, or if I don't want to, persist like some sort of device token that I want to stay there after the user installs the app, like why not just use user defaults?
There's no big reason to do it. So there's no benefit of using Keychain unless you want to have some of the protections. And also another reason is that you might want to have is the Keychain has this attribute of not being backed by the backup. So when you're, let's say there is another case, there are actually so many case studies I can go through. Another case when imagine you have the per seat licensing on your application, and then you have a user copies the backup to the computer and then restores his another device with that backup. So now you got the apps running with the same state on both devices. Essentially, you have a per seat licensing, but you got the app running on two devices with the same seat. And in this case, the Keychain, you can set the attributes so it will be this device only, and that is one of the ways to that you can prevent this behavior. So yeah, you have this one of the examples. And
yeah, we've had this bug actually. I think something's very similar.
And this is the way it's shown here. Accessible when unlocked, and this is this device only. This device only means it's not backed up to the iCloud. It's not backed up to your iTunes or how is it called, backup. So one of the cases like that where you might want to have Keychain still.
Thank you.
Hey, thank you for the presentation. It's maybe not related to the Keychain, but I'm just wondering, do you use kind of enforcing users to repeat their passwords if they use constantly just biometrics authentication?
Can you repeat the question first?
Do you enforce people to repeat their password keys if they use only biometrics? To not forget the password, for example.
Now, I mean, it's a UX question. I don't even have a say or like thinking about it. I'm like in this project specific where this technology has been used now, but you can do that if you want.
Okay.
Like this is really not related. What is important is that you will have to ask for the password when the biometric changes. There's no way, if you design it this way, there's no way you can get the password from the device.
Yeah, thank you.
Hey, thank you for the presentation. So I have a question. Can the user defaults be always trusted if you like that there is a reset if you reinstall the app?
Sorry?
Can the user defaults be always trusted that there is a reset of data if you just reinstall the app?
I think in the case of the app groups and some other apps present in the device, it might not be clear. But in that specific instance, the way I've shown it is that it stores in the standard user defaults, so it doesn't store in the app group. In that case, it should be erased.
What about like backups? If you delete the app, but you have a backup?
If you have a backup, then the user defaults are backed to the backup. Then you restore it, and then you restore it back. then your device is in the same state it sort of used to be. So the backup and restore process is sort of transparent. So here you decide how you want to make it work. In that case, if you want to, you can set the keychain keys to be current device only, and those will be cleared. Or if you don't want to, you can allow the backup, and then your everything will be restored. So that depends on your application design.
So it cannot be like always trusted.
Well, that's one signal. Another signal is the keychain keys themselves. So in that case, the key will be erased, right? One of them in the backup, so you can get the behavior you want. But the user defaults is transparent for the erase and restore process. But for the user defaults, it doesn't. The user defaults don't see that. In the file system, they don't see it. For them, I think you can set a flag, but for the user defaults, they don't see the process of backup and restore. It's like it was like nothing happened. For Keychain, there is a difference. You can define the behavior you want. And since your keys depend on both cases being present, the keychain keys present, and the encryption key present, if any of those are absent and you can control both, you can get the behavior you want.
Okay, thank you very much.
Yeah, what happens if you hit the kind of storage limits and let's say some apps leave the encrypted data lying around? So does it like eventually clean up somehow the keychain data?
I don't know the answer to this question. I don't think you can hit the limit. I think the limit is per app.
Yeah, thanks. Just one question. I think you touched on it a little bit in the introduction, but access to the keychain when running in the background, is that possible, or what are the constraints on that?
Yeah, it is possible as well. So I didn't touch about this topic. It's an interesting topic, and I probably could put 20 or 30 more slides on that. Yeah, another challenge is the access control attribute, and you can have different ways to control the access. You can have it background after first unlock, only in a foreground, so device unlocked. You can put different security levels. You can put the always attribute, which means that the data will be always accessible to the applications. There are quite many options in that as well. Very flexible. And one of the bugs that happens usually is that you enable something accessible in a foreground, and then you try access in a background, and you get the values missing in something. And then let's say if it's a token, you log the user out in the background. That's usually what kind of bug might happen. Very common one.
All right, I have a question as well. Have you played around with Apple Watch and sharing keychain between the iPhone app and the Apple Watch? And how do you do that?
I didn't do that because I just didn't have Apple Watch.
All right.
But I don't think there would be any much difference than what I've shown so far. You just have to have them in a group, and you have the watch extension, and then you have the app group. If you can do the app group access, you can do everything that you can do with the app group, including the keychain sharing. Any more questions?
Thank you. So you had that one implementation with Codable. What's the size limit of the data blob that can go into Keychain? And
I don't remember. There is a limit. So you can't store big structs, for sure. You can't store images or like something huge. There is no, not unlimited.
Yeah. And if you had an API like that, how would you even try to like check the limits or control that?
Usually you don't do any checks because you want, in my view, you do it transparently. So you want to have the keychain error, you just throw it back to the caller. As I've seen in the first slide I've seen in the implementation is the error processing. So I try to have these layers to be very shallow, very transparent, so that it's very clear what's going on under the hood, because keychain errors are very difficult to trace. So if it's over the limit, the keychain will tell it, and or at least it will tell some cryptic error that you might be able to decipher in the upper layer, but not mingle it in some way.
Right. And then because it's a codable type that might change over time and the data can come from wherever, it can change over time. And like you, as a user of the API, have no way of actually testing it at the moment. Like it's a tiny type, and then over time it grows and it just starts exploding in the production, for example, because of some changes.
Well, it's your responsibility as the user to store, to define the type and to control it. It's a very good question. It's very important with this implementation, unlike with those predefined ones where you have string, boolean, and a few other types. You have to be very responsible, and if you add one value that is not possible to decode anymore, it will fail, of course, at the decoding stage.
Yeah, but that was kind of my question. How can you control that? Because you have no way of controlling the type of evolving over time.
Well, one way is that you create your keychain types really clearly, like you have a specific data transfer object specifically reserved for the keychain operations, and you don't change them from the app one, from the version one. And then another way is that you can use migrations. You'll have to keep two versions of your object if you use Codable at the same time, and then you migrate one object to another, store it, and delete the previous one if you want to add a few attributes or something else like that. And but it's mostly not for structs. I would think it's mostly for enums or integers, like to add the support for those types really quickly, because all of those integers, everything can conform to Codable. So can or enum, which is a very popular type for settings or different kind of values. So not for structs. I wouldn't even use something big for that.
Yeah, you as an API creator wouldn't, but if I have a chance, I can use it wrong.
That's the documentation is for, but generally you write this stuff for yourself. I would usually use the wrapper if I have to. In fact, in one of the latest projects, I used the ready-made wrapper. I didn't write it. In 99% of the cases, I use the wrapper myself, even after I've told that. So after I've shown this presentation, I still use wrappers just to show that I don't do the implementation just for the sake of it. So if you do something like this, you probably want specific behavior you need and so forth. If you do it for the company, for other developers, you document it really well.
Yes, hello. For the first, thank you for your presentation. It was quite informative and helpful, I guess. So my question is actually about to go further with one of the questions of the previous speakers, like the visitors, about the situation when actually user changed biometry keychain. So there is a way actually how your system is gonna react for temporary changes on your biometry, like maybe for injured finger or maybe blacked eye face. And the second question, if there is a way how you can actually set up the code to secure this way from any kind of mistakes and errors that is gotta be because of these temporary changes.
What is temporary change in biometry?
Yeah, I mean injured finger, like when you cut through the knife, or maybe a blacked eye face.
So if that is the case, then there will be failure to authenticate the user, and then you will not be able to retrieve the data if you protect it biometrically. So
yeah, but if there is a way how you can actually protect your system from these kind of errors, because when actually the user cut his or her finger, so it's not actually his fault to lose and erase all of this protection system.
the way to protect is to have the biometric factor is always a supplementary factor for the authentication. It's never a primary factor, which means that you have some other primary factor like a password or a PIN code or something else that is the real factor to authenticate the user.
All right, gotcha. Thanks.
All right. Thank you very much for the questions. And thank you, Richard.